Here we go. So have you seen this kind of function where you have this brace and then you actually have two functions? Have you seen that before? It's called a piecewise function. You definitely have to be able to recognize this on the test and perhaps graph one. So let's go through graphing this thing. It literally is made up of pieces. So it is a line x plus 5 for every place where x is greater than 0. So all the positive x's would be here on this line. What is this? What kind of line is -3? What does that look like on the graph? Y equals -3. What would that look like? A horizontal line, right? So for everything where x is less than or equal to 0, you've got this horizontal line. So you're going to have this piece and a piece. We need to see that on the calculator, all right? So I'm going to put my calculator up here and we'll do it together. So you've got your calculator and I'm going to have mine. Okay, so we'll clear and I'll go to y equals and clear out anything that is there. All right, when you do these, the function itself, the x plus 5, needs to be in parentheses. The parentheses are above the 8 and the 9, so you're going to hit your open parentheses above 8. Whoops, I should be up. Right there. And you're going to put x plus 5. Everybody know where the x is? The variable key? All right. So we're going to do that. And then we're going to put our little parameter in parentheses as well, the x greater than 0. So we're going to open another parentheses. And we're going to put our x. Where in the world are we going to get our inequality symbols? If we go to second math, do you see them? Second math, okay? And we need greater than, that's number 3, okay? And then I'm going to put 0 and close parentheses. All right, so once you get line 2 in and line 1, you also want to make sure that you are in dot mode. And it may be different on your calculator than on this one. I need to actually change the style of this one. Hold on. Let's see. Let's change the view so that it looks like yours. Oh. So now it's not in at all. Okay. Of course.
And it always needs to be dotted into the piecewise.
Yes. And I'd like mine to do the right thing. This emulator is great till it doesn't do what it's supposed to do. Okay. Should be 3 dots like I've got on mine. It's not wrapping? Everybody get that? And we're good? Okay, so you would be matching it. The only thing your calculator will not do, let me grab that picture. Where'd that go? Somewhere. Okay. So the only thing it won't do is put open and closed circles. So for x bigger than 0, should this circle be open or closed? It says x is greater than 0. What should it be? Open. So you should have an open circle. If you were matching it, it might have one open and closed, and that's the only thing your calculator won't do. Less than or equal to 0, what should it be? Closed. So you are looking for an open circle here and a closed circle here. So if you were trying to match it, that's what you would want to be looking for. All right? Does that make sense? Okay. All right. If I ask to graph a polynomial function just like this, We can do part of this by thinking about this. Is this all factored? It's already factored, right? What would be the solutions, or what would be the x-intercepts? Because it's already in a nice form. What would be the x-intercept for here? Okay, so x is 2, x is 1. What would this x be? 0. Because see, we take each piece and set it equal to 0. And so x is 0. So if you looked at this, and I suspect you'll have something like that, you can know what the x-intercepts are before you start anything. So I could put a dot at 0, a dot at 1, and a dot at 2. I know that's where it's going to cross the x-axis. I don't necessarily know what the thing looks like. If I were having to graph by hand, that's what I'd want to do. I'd want to know where those were. But let's go to y equals and put that thing in and see if that's what happens. So go to your y equals. You don't need dot mode anymore, and it will go away once you hit clear. Okay, so up here we want to put 3x and then parentheses x minus 1, close, open, x minus 2. All right, and then you can just hit graph and see what you get. I can't really see it very well. Do you know how to get in and look at it a little closer? You could do a zoom 4, would give you a nice view. Zoom 4. And where did it cross? 0, 1, and 2. So if I were just having to do that by hand, I could do that. I could see that. In your test, if you were doing that, if it asks you to do that, you now know you could just throw it in y equals and see what it looks like. You want to make sure it's crossing at the intercepts. Everybody okay on that one? Okay. Okay, this one says graph a rational function. Do we know what a rational function is? Does it look like a fraction? Yeah, it's a ratio. It's two polynomials, one over each other. But we need to be able to graph it. If you were graphing it with your calculator, can you put the top in parentheses divided by the bottom? So in other words, y1 would look like x minus 4 divided by x plus 5. And it's important to have the parentheses. So let's put that in and see what that looks like. I think I'm going to go back to a zoom 6 and let's see if we can get a better window. There we go. Do you get those two pieces? So next one is an exponential function. Exponential function is totally different than linear and quadratic and polynomial. What is different about an exponential function? Where's the variable? He's in the exponent. That's totally different. That's a whole nother world. And so that looks different. But we can do that on our calculator. If we grab our calculator, go to y equals, clear what's there, 2. When you need to put something up in the air, your caret key is right here under clear. So 2 to the, now if you have an older calculator, it's just going to have the caret there in a parenthesis, and you put what's in there. But we have a box, so x plus 4, and then we're good. 2 to the x plus 4. Let's hit graph. Okay, that's an exponential function. We talk about things increasing exponentially, like populations or rabbits They multiply exponentially. Elements decay exponentially. So they're important functions, and we have a whole chapter on them in college algebra. So you need to be able to graph them. We'll do some other things with them as well. Okay? Let's see if I can put that over there. All right, so that's what that one looks like. All right. How about polynomial inequalities? If we were going to solve that, it's saying where is x squared minus 6x minus 6, where is that less than or equal to 0? You can certainly do that by hand, but you can also do it on the calculator partly. So here's how I would show you to do that. Let's go to the calculator and put in y1. Let's just put it in as an equation. All right. So we'll go here to y equals. We'll clear out, and we'll have x squared. You can just hit the squared key. Minus 6x minus 7. Okay. Let's hit graph. That should be just what? A parabola? Everybody get something like that? Okay. I want you to sketch that on your paper. It doesn't have to be perfect, but let's just sketch it. Okay, so you have this picture of your parabola. Now I want you to look at this symbol. Does that have an equals under it? So that means less than or equal to 0. So we need to have a closed circle there on both of those x-intercepts. Now, if it's less than, we're going to be interested in below the x-axis. If it's greater than, we're going to be interested in above the x-axis. If that's something you need to write down to remember, I would write it down. That symbol, less than, is below the x-axis, and greater than is above. And whether you have an equals or not, it's still generally that. So we're below, which means I'm going to shade in. I can't see the bottom of it, but that's what we're talking about. We're talking about that region, okay? I need to know what these numbers are. Let's talk about how to find those. When we want to find those numbers, those are the x-intercepts. What's this graph, what's this line called right here? X-axis. What's the value of y there? When you're on the x-axis, what's the y value? 0. 0. So if I went to y equals, and in y2, I put 0. It doesn't change the picture of my graph at all. But now if I want to find the intersection of the x-axis and my parabola, I can do that, okay? Did you find any intersections before? Let's do this. Let's do second calc, which is the trace button. Is everybody doing that with me? Second calc, you get that menu. We want to choose intersect number 5. And we want to hit enter 3 times. 1, 2, 3. So we're going to repeat that process, second calc 5. But before we hit enter, we need to get over there to that other guy. So we're going to use our right arrow to move, because graphs move left and right. So he's moving around. He'll be coming back up soon. All right, when you can see him flashing, you can hit enter 3 times. What do we get? X is 7. Okay, so your sketch now should look like this. Whoops, it should not have that. Okay, you should have x equals 7, and x equals -1. Oh, goodness. -1. Do we have that? Okay, if we've done it correctly, our solution is right there. It says it's from here to here. So our solution is from -1 to 7. And we use brackets for that because it's got the equals. Brackets because it's got the equals. So this is interval notation. Inequality would be that x falls between 7 and -1. That would be the answer if they asked for inequality notation. Okay. Write an equation given a slope and a point. Does that sound familiar? Okay, so for this one, you're going to need this form, y minus y1 equals m times x minus x1. We're going to plug in what we're given. So we're going to have y minus 3 equals -7 times x minus 4. Does that make sense? Yeah, okay. Then we clean it up a little bit. So we're going to distribute. And then we're going to add 3. Did I do all that right? Okay. All right, so we're good on that one. Okay. That probably is fairly fresh. All right. Okay, this one, write the equation of a line given the slope and the y-intercept. Now you're given this in a picture, not in an equation. Okay, so where's my y-intercept in this picture? Okay, so my b, my y-intercept would be 5. And my slope, I can find by saying if I went down and over, so how many did I go down? 5, and I went over 5, so my slope is -5/5 or -1. Is that right? So what is my equation? If I have those things, what would my equation be? Okay, so y equals -x plus 5. So you might be asked to look at a graph and write the equation. And so you want to find the y-intercept and go from there. Okay? All right, is this your very favorite thing in the world, solve applied problems, word problems? No. So we read this part, and now we're saying during its hop, its height is given by an equation. So we have h equals -0.2x squared plus 1.7x, 1.75x plus 7, where x is the distance from the base of the reed. So x is how far he is from the reed, and h is how high he is, right? H is in inches. How far was the grasshopper from the base when it was 3.25 inches above the ground? So let's think about something. The 3.25 inches, is that an X or is that an H? It's an H. So he was 3¼ inches above the ground, and it's saying, how far was he from the base? X is the distance from the base. So we're trying to find X. So this is actually saying 3.25 equals -0.2x squared plus 1.75x plus 7. Now, you could solve that by hand, but we can totally do that with our calculator, right? Because you've got this y equals has to be equal to this y equals. We're going to find the intersection of those. So let's go to our calculator and put the original, put this height in y1 and put 3.25 in y2. Okay? So negative 0.2x squared plus 1.75x plus 7. That goes in y1. And y2 is 3.25. And so we're saying, when does our height function intersect with 3.25? Let's see what kind of picture we get. Okay, did you guys get a picture like that? Okay, I'm going to put that there. So this is coming on down here. Okay, we have two places that intersects, but what is this? Is x positive or negative here? Do we have negative distance? No. So we're going to ignore that guy. We just need to worry about this guy. Now, back on my calculator, I can't see where it actually hits. What do we need to change? Okay, if we go to window, what do you think we need to change? We only need to change one thing. X min or X max? Min is on the left at negative, max is over here, so we just need to make the X max bigger. Let's make that about 15. Sometimes it's just a guess. We just see if it works, and then hit graph. Perfect. All right. We're trying to find this point right here, the intersection where those two meet. So second calc 5, and then enter. We got that one. Okay, so I didn't need that one. It just popped. I didn't pay attention. Let me go get the other one. Second calc 5, but I need to move over till I can see him. Okay, I can see him. All right, he just kept moving. And then hit enter 3 times. Did anybody get that? 10.53? Okay, so that is how far he was from the base of the reed when it was 3.25, when he was that high in the air. Okay, so your answer would be the 10.53. So we said this was, what did we say this was, 10.53? Okay. All right. What if I asked you to identify whether this function is even or odd? What do you think? Do you remember studying that? No. Okay. Okay. For one thing, odd functions, if you have the equation and you look at the exponents, if they're all odd, it's an odd function. That's pretty easy, right? If they were all even, it would be an even function. But what if we had this? We have one of each. So that's neither. And this is odd. Okay? Also, even ones, if you just saw a picture, an even one is symmetrical about the y-axis. What does symmetrical mean? What does it mean if something's symmetrical? Same on each side. So if you fold it, it would look the same? Absolutely. So an even one is the same on both sides. That would be an even function. An odd one is like this, and it's symmetrical about the origin. And it's hard to tell sometimes by a picture, but what happens is if you rotated this guy 180 degrees, it would be the same graph. If you flipped this thing around, can you see that it would be the same graph? That's symmetrical with the origin. That's odd. Even is symmetrical with the y. Okay.
Wait, so even is symmetrical with the y?
Mm-hmm.
The odd was right?
Symmetrical with the origin. This is odd. And even is symmetric with the y. Now, none of that has to do with this particular question. We just kind of went a little bit further here. This one's odd, and you can tell that by the exponents. All right, please tell me, have we done quadratic formula? Yes. Okay. All right. So if we're gonna, we would look at an equation, and I tell people, look at it first and see if you can factor it. If you can factor it, you want to do that because it's a little more work to do the quadratic formula. Can we factor this thing? What are the factors of 85? What goes into that? Okay, 5. So if I said that's 5 times 17, those are both prime. So that's it. That's it as far as my choices. Are those going to give me negative 14? No. So we know this doesn't factor. We know we need the quadratic formula. We need to know what A is, what B is, and what C is in this equation. Before you decide on A, B, and C, you always want everything on the left, in order, descending order, and equal to 0. So in mine, what is A? B is? Good. And C? Awesome. Okay, and so you need to remember what the quadratic equation is. Negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, so then you're just going to be plugging in. So we have negative 14, and I would urge you to put things in parentheses if they're negative so that you don't mess up on signs. Plus or minus square root of negative 14 squared minus 4 times 1 times 85 all over 2 times 1. So you try that part that's inside the radical. Could you figure out what that is for me? That would be great. All right, so we've got positive 14 plus or minus the square root of negative 144 over 2. Everybody agree? Okay, so we've cleaned it up that much. What does that negative inside the radical tell us? It's an imaginary number. We're going to have an I in our answer. That's perfect. Is 144 a perfect square?
Yes.
Okay, so what is this part equal to then? 12i. So we got 14 plus or minus 12i over 2. The test is going to expect you to completely simplify that answer. And by that I mean if the radical needed to be simplified, we would do that. This one worked out really nicely. But are all three of those numbers divisible by the same thing? They're divisible by what? 2. So if I go ahead and do that and say, well, that's 7 plus or minus 6i, and the 2's gone on the bottom, right? So this is our answer. 2 solutions, 7 plus 6i, 7 minus 6i. All right, if I gave you this thing and said, solve this equation, do you have a suggestion for how you would do that one? Okay, so the first thing you really might want to do is throw it in the calculator and see if you see a real solution. So we go here, we clear, and we clear, and we're going to put in x to the third plus 5x squared plus 49x plus 240, why am I not in the y equals? And you guys should have told me that, right? At the start. X to the third, and then I have to remember to come down, plus 5x squared plus 49x plus 245. And put y equals 0 on the y2. Because what we're going to do is say, where does my function hit the x-axis? So if I hit graph, you just see like a straight line? So this thing has one real solution and probably two imaginary. Well, we can find this guy. Let's find it. How do we do it? How do we find an x-intercept? Second, calc 5, and enter 3 times. Did we get -5? Okay, so we're going to write that down. We found one solution, x equals -5. All right. We'd like to get this thing down to quadratic, so let's divide -5 into it with synthetic division. Let's write our coefficients. We would have 1, 5, 49, 245. I don't know how you learned it. This is how I teach it. I do a backwards L and I put -5 there. Is that what you did? Good. Okay. Then we would draw a line. We bring down this one. And from there on, it's multiply and put your result here and add. So -5, and we add, we get 0. Multiply, we get 0. Then we have 49 here. Multiply, and we get -245, and we get 0. And you should get 0 on the end. Why? Why should we get 0? There's no remainder. We knew it was a factor. We knew it was a solution. Now, if we want to return this into x form, what is it? Plus 49. Okay, no x's. I'm going to set that equal to 0. Now I can solve a quadratic. Okay? Can I subtract 49 from both sides? And then take the square root of both sides? What's the square root of -49? 7i. So x is plus or minus 7i. So now I found my 3 solutions. It was a cubic equation. That meant there were 3 answers. I found one by putting it in the calculator and finding it. That was the real one. And then I whittled it down to quadratic with synthetic division. And then I could find the other 2. Okay. Find the domain of a rational function. Well, we looked at that when we graphed one. We said it has a restriction because it can't be 0 on the bottom. So here's your technique. Take whatever's on the bottom, take it over here and set it equal to 0. And let's solve that thing. How can we solve that? Yes, we could. We could take out an x, and that leaves x plus 4. And then each of those setting equal to 0 gives us x is 0, -4. Now, is that my domain? That's not the domain. Those are the restrictions. Those are the restrictions. Those are what x can't be. And so you might see a formal, in the answer, you might see a multiple choice thing, and you would see a brace, all x's such that x not equal to 0, -4. That would be maybe the way the answer was written. X can be anything in the world except 0 and -4. Yes, that would be the domain. All right. Here's two examples of rational functions. And you might be asked, I kind of combined two things. Identify a vertical and horizontal asymptote. What's an asymptote? Okay. All right. Well, an asymptote is a boundary. All right. So a vertical asymptote, we worry about the bottom. It's what gave us the restrictions on the domain. So the same way that we took that and set it equal to 0, we're going to do that here. X squared plus 6x minus 27 equals 0. Does that thing factor? Yeah? What would we get? Plus 9 and minus 3?
Yeah.
Okay. So when we're sure that's right and we solve each of those, so we get x equals -9, x equals 3. Those are the restrictions. Those are the vertical asymptotes. There's a page in that yellow packet, I think it's the second page, that talks about what to do to find a vertical asymptote, but that's what you're doing. You're finding, what are my restrictions in this rational thing? What are the lines? What are the boundaries? Okay?
So the horizontal and the top, the numerator?
It's going to be a combination. We're going to do that with the second one here. We're going to do that here. Okay? So everybody okay with the vertical ones? Same thing that you use to find the domain restrictions. Horizontal deals with the comparing the top and the bottom. Okay? So if we think of, do you know what degree is? What's the degree of this thing? 2. So it's the highest exponent, right? So the degree of the top, I'm going to call it n. So the degree of the top is 2. The degree of the bottom is 2. So we're always comparing the degrees. N is degree of top. M is the degree of the bottom. All right. If n equals m, your horizontal asymptote is y equals, go get the coefficients of the top and the bottom. Y equals 5/7. Y equals 5/7. Right. And there's a whole, all right. We have one other kind of asymptote, and it's called a slant or an oblique. It only occurs when the degree on the top is exactly 1 bigger than the degree on the bottom. Okay? Is that the case here? Mm-hmm. Yeah. And when that happens, we have to actually divide to get the slant asymptote. We actually divide x minus 8 into that. Can we use synthetic division to do that division? We can. So we're going to write the coefficients 1, 9, -9, and we're going to divide by what? 8, positive 8, okay? So 1, 8, 17. We can stop right there. When you're finding slant asymptote, you don't have to even worry about this remainder. All right, if I turn this back into x's, what is that? We started out with squared. What's this? Okay, so y equals x plus 17 is our slant asymptote. It's a slanted line. It's not a vertical or a horizontal. All right, so you will have to probably do a composite function, and you'll be given an f of x. So here's my f of x, and here is my g of x. And you could be asked to find f of g or g of f. And what does that mean? F of g means take g and put it into f. All right? So we're going to do that. We're going to say 3, and instead of x, I'm going to write this whole thing. 4x minus 1 plus 11. And then we distribute, and we get 12x minus 3 plus 11 is 12x plus 8. Okay, combine functions using the algebra of functions. This isn't compositions, it's saying, okay, you're given two functions. We've got an f of x and we've got a g of x. And I want to know what f minus g of x is. Well, you simply subtract them or add them or multiply them, whatever the operation is. So I'm going to take this guy, 9x minus 2, and I'm going to subtract this one. I suggest you put that second one in parentheses if you're subtracting, because what's going to happen to both signs? It's going to change them. So we would have 9x minus 2 minus 7x plus 8. And then we would collect like terms. What would we end up with? Two x plus 6. Okay. All right, good. So the question would just say, find f inverse. That's the terminology that you would see, f with a -1 up there. The steps are, first step is write it as y instead of f of x. So you would write y equals 3x plus 7. Then you switch out the x and the y, so you have x equals 3y plus 7. And then you solve for y. So how would I solve for y? What would I do? Subtract 7, so x minus 7 equals 3y. And then divide by 3. So x minus 7 over 3 is y. And so f inverse is x minus 7 over 3. And that should make sense because you're finding the opposite, the switch. In inverses, the x's and the y's all trade. So over here, what were we doing to 3x, to x? We were multiplying by 3. Here we're dividing by 3. We were adding 7, we were subtracting 7. So those do look like opposites of each other. Okay, so if you were putting some money in the bank, let's all be excited that we have $12,000 in the bank and we're getting paid 5% interest compounded quarterly for 9 years. Our formula is A equals P parentheses 1 plus R over N raised to the NT. That's our formula. Okay, that's what that is. Now, what's P in our work here? P is the principal. That's how much money you got in the bank. What's R? That's the rate, and if we're doing it by hand, we'll use 0.05. And N is what? N is the number of times you compound. So if we're doing it quarterly, how many is that? 4. So we've got a P of 12,000. We've got R is 0.05, N is 4, and what's T? 9. T is the time in years. What if I told you the time was 18 months? Would you use 18 for T? You would have to make it 1.5. It's time in years, okay? All right, so let's do that. Let's put this in. A equals 12,000 times 1 plus 0.05 over 4 raised to the 4 times 9. When you're doing all that in the calculator, I would start here, and I would say 0.05 divided by 4, enter. Plus 1, enter. Raised to 36, enter. And then I'd multiply by 12,000. That'll help you in not getting in trouble with that. Did we get something like that? Anybody? Okay. And you know, when you're doing things like that, it needs to make sense. If you got something like 10,000 something, would that make sense in your question? You wouldn't have earned any interest. It would not have worked. So you need it to make sense. Okay? Now, if you want to do it on your calculator app, I'll show you that real quickly. If you look at your calculator, let's quit out of that. Right in the middle here, next to math, is a button that says apps. So hit apps. Top one is finance. We want to hit enter. We want to go to the solver. That's it. All this is in your yellow packet as well. So hit enter. Now, we've got an n, but it's not the n that we just used. It's total compounding. So we compounded 4 times a year for 9 years. How many total is that? 36. So let's put 36 for n. For percent, we don't have to use a decimal. We can just put 5. PV is present value, so let's put our 12,000 there. We don't need to worry about a payment. Future value, that's where we're going to solve. But let's go down to payments per year. How many times are we compounding for a year? So let's put 4 and enter, and it should change that one to 4 as well, right? Okay, what we're trying to find out is how much money we got at the end. So let's go back up to future value. All right, above the key that's enter, what do you see on the right? What word do you see? Okay, so alpha is the color that matches mine. Alpha and solve. What number did we get? 18, same number we had? Oops. Isn't that the right number? The only thing is, it's negative here on the calculator. Ignore the negative. It's a positive. Okay, but that will work if you wanted to do it that way. You know, it's not hard to use the formula, but some people like the app. Okay? Yes? Look at these. All right, change from exponential to log form. All right, you might want to write this down. Base to exponent equals argument. Yeah. Log form is log base of argument equals exponent. Those are the two forms. You've got one of each right here. Does this look like it matches this form right here? This first one? Okay, so what's my base here? And what's my exponent? X, and what's my argument? 684? Okay. Down here, does this guy look like this one? What's my base? What's my argument? And exponent? Okay, so the question will just say, change this from exponential to log. All right, so I got to take all the pieces and make this into a log equation. So this is log, what's my base? 3. What's my argument? Equals x. So that would be that one. And what about this one down here? I want to change this to exponential. What's my base? And what's my exponent? Equals x. It might say solve symbolically, and that just means change the form to where x is on one side and everything else is on the other. Okay? All right. How much do we lack? 30 minutes. Wow. Okay. Do you guys know about expanding log expressions? Because I'd rather get to something you don't know. If you know how to do this, you know how to do this?
We just did like log stuff.
Okay, so that's pretty fresh. Okay, so that would be okay. And condensing logs, you'd know how to do that. Change a base formula, do we know that? Because on your calculator, you don't have a log base 4.2 key, right? So for change, so you can use the formula like here, or you can go to your calculator and go to math and up. I think up is easiest. Go and hit log base. You get this and fill in the blocks, and that would be good. Do you know how to solve a log equation? This guy? So if we're going to change to exponential, the base is 10. The exponent is here, so 10 to the first equals 4 minus x. That gets rid of the log thing, which makes it difficult to solve. So subtract 4, so I have 7 equals negative x. So what does x equal? Negative 7. So when you see a log equation, change it to exponential. All right. Second matrix, and we have 3 menus there, names, math, and edit. We're going to use all of those, all right? So the first thing, we'll just put the first one in A. We're going to go over to edit and hit enter. What is the size of this matrix? If I have, how many rows do I have? How many rows do I have here? 3. And how many columns? 1, 2, 3, 4. So is this a 3 by 4? All right, so I'm going to put a 3, enter, 4, enter. So I should have a blank matrix where I could put in the coefficients. So in my first row, what would I have? 1, 1, 1, 6. And it should pop you to the next row. Now, why we don't have a y. So we're going to have 1, 0, negative 1, negative 2. All right, in the last row, we don't have an x, so we're going to have a 0, 1, 3, 11. And with matrices, you want to be really careful that you put things in correctly. You don't want to miss something because you just had a number in wrong. All right, let's do second quit, which is second and the mode key, so that we're out of that. We're going to go back in, second matrix, over to math. Okay, so let's go back into matrix and over to edit, and let's just check your numbers and make sure you have them in all correctly. So 3 by 4, and so you should have right up here 1, 1, 1. We'll get the last column in a minute. 1, 0, negative 1. Did you find something?
Yeah, I missed the 1.
Okay, and then 0, 1, 3. The thing is about a computerized test and using your calculator, you're not necessarily going to know if it's not a multiple choice that you haven't gotten it correctly. So I would really urge you to, once you put them in, go back and look at it and make sure, do I have the right numbers in? And then go on. All right, so now we'll second quit. We'll just do this one more time. Second matrix math, and we'll choose RREF. It's really quicker to go up. So once you're on RREF, you hit enter. We go back in and get the name of the matrix and hit enter, and enter one more time, and you should get 1, 2, 3. Is that right? Okay. Okay, if you want to find the inverse of a matrix, we want to put it in first. So let's go put it in.
Is this the last one?
Yes. Yeah, we skipped. All right, so let's go back to second matrix and over to edit. What size is this? 3 by 3. So 3, 3. All right, and then we've got 1, 0, 8, 1, 2, 3, 2, 5, 3. All right, and I'm really bad about putting them in on this little emulator, so I always have to check and see if I've got it in right. Okay, do we all have it in? Okay, so second quit out of it always. And then we just need the name of the matrix. So let's go back in, second matrix, and grab A. And so the calculator's saying, okay, what do you want me to do with A? The inverse key is right where we've been hitting for matrix. So just hit that matrix button. And we're telling it to do the inverse of A. And there we go. Did I put them in wrong?